Okay, so all along we've been saying that a log is an exponent and that all those exponent rules actually apply to logs. Well, today we're going to actually bring those two worlds together. And it doesn't seem as important when we're dealing with just actual numbers. But when you look at questions like you see here, if log base A of P equals 7 and log base A of Q equals 2, find, now do this. Because if we have numbers, we just plug the numbers in and it's no big deal. But now we've got this P and this Q thing, and how do you deal with that? And so our whole point of learning these log rules is, what do you do when you have a bunch of logs that you can't actually solve? Just like in the previous lesson when you had 3 to the x equals 10, or when you had e to the x equals 8. And all we could do was actually write them in the form of a log. We couldn't come up with the exact number. So what I want you to see is that those principles that we learned with exponents do in fact apply here with logs. So we have log base A of P and log base A of Q, and we have what they equal. So let's see how we can actually evaluate this. The first question says log base A of P divided by Q. Now, when you're dividing exponents, what are you actually doing? Subtracting. Great. So what I want you to think of is, this is a log, which is an exponent, and we're dividing. So therefore, what we're going to do is we're going to subtract. Now, I want you to be very careful, because what typically people do is they automatically just put the 7 in for P and the 2 in for Q. That is not what this says. What this actually says is that the log base A of P is 7, and this says the log base A of Q is 2. See, that whole thing goes together. It doesn't say that Q equals 2. And so, in doing so, when we separate this is how this works. It would be the log base A of P minus the log base A of Q. And so we put the log base A of P, which is 7, minus log base A of Q, which is 2, and we would get 5. Okay, now let's look at the next one. Again, think through your exponent rules. What do we do when we're raising an exponent to a power? Because a log is an exponent. And so when I'm raising it to a power, what are we actually going to do? Multiply. And so here we are. What this looks like, though, is we take that 2 and we drop it down in front. So it becomes 2 log base A of P. And so that would mean, again, log base A of P, as we look above, says 7. So it would be 2 times 7, which is 14. In C, we see log base A of P times Q to the 4th. Again, notice that only the Q is being raised to the 4. If that 4 was on the outside of these parentheses, we'd have a different question. This is saying P times Q to the 4th. So first, let's deal with this. Let's first look at the fact that these are multiplying. And so again, we're going to write that as log base A of P plus log base A of Q to the 4th. But hopefully from the previous question, you remember that that 4 would drop down in front. So another way of writing this would be log base A of P plus 4 times log base A of Q. And so log base A of P is and 7 plus 4 times log base A of Q, which is 2. And so that would give us 15. Great. Now let's look at some more examples dealing with logs and handling them. So we have 2 log base 2 of 8. Now, in a previous assignment, you looked at these and hopefully started to recognize some pattern that was going on here, and that's really what I want you to examine. I'm just going to start originally here by taking it kind of slow, and you can look at this. When it says 2 to the log base 2 of 8, let's first look at what is log base 2 of 8. Well, that's 3, right? 2 to what power is 8? So then that's really saying 2 cubed, and so that answer is 8. Is there a way, though, that I can look at this original question and say, could I have come up with that answer 8 in a different way? Let's look at another one and see. Log base 2 of 16. Well, that's 4. So then the question is 2 to the 4th, and so I get the answer to 16. Is there a way that I can jump, again, from the original straight to here without that lovely intermediate step? Do you see it? What do you notice that we can do? Do you notice here that 8, and that 8 were there, and 16 and 16? Because remember, this is saying 2 to what power is 16, and this is saying 2 to that power. That's what that's saying. And so it's telling you to come up with the value that it's saying there, because this is an exponent. That log is written as an exponent. So 2 to whatever power that happens, it's going to give us 16. Well, that's the one I want. And so if I have this next question where it says 2 log base 2 of 10, the first thing you have to pay attention to is that they're both of the same base, 2 being raised to log base 2. In essence, if you want, you can almost think like, hey, they cancel each other out, and the answer to this is 10, because that's in fact what's happening. 2 to some power is 10, and so 2 to whatever that power is, what does that equal? It equals 10. Okay, let's look at another one. 2 log base 2 of a. 2 to some power equals a. I don't know what that power is, but take 2 and go to that power. What would we get? We would get a. All right. ln, recall that ln is log base e. Don't let that mess you up, because the e and the log base e are one and the same, or e and ln are one and the same, and so the answer to that is just x. So then when we look at a numerical one, e to ln of 2, again, think of it like they cancel, and you would get 2. This next one's a little tricky, because you want to say negative 2. But remember that when you have a negative in the exponent, that it actually, and we can look at this a couple different ways. From the lesson that we just did here, just a few minutes ago, we learned that a number comes in front when it was actually in the power. So another way this could have been read as e to the ln of 2 to the negative 1. And so when this cancels, this would be just like 1/2. Another way to think of that is we have a negative exponent. And so whatever that answer was for ln of 2, it means we're going to flip it and become 1/2. Let's look at this one. What about if I write it in this form, where I write it as a log base 2 of 2 to the 5th? Now again, we could figure out that log base 2, we could say, okay, that's 32. Well, 2 to what power is 32? Well, it's 5, of course. 2 to what power, because remember this question, this is saying 2 to what power equals 2 to the 5th. It almost seems ridiculous to ask such a question. And I want you to think through that as you're doing these questions. How, in fact, could I answer then log base 2 of 2 to the a? 2 to what power equals 2 to the a? Well, of course, they're the same base, so x equals a. All right, again, ln is log base e. So this is really like log base e of e cubed, much like log base 2 to the 2. So we have, again, the ln, the e, the answer would be 3. E to what power is e cubed? How about this one? Maybe you want to rewrite it. I don't know. If you don't need to, great. Then hopefully you can see right away that the answer to this one is negative 2. How about this next one? It's almost too simple to answer. ln of e. I want you to come up with an answer for me. This is the question that I'm going to be looking for. ln of e. I would like to see that you know how to do that answer. Come with me and give me a guess what you think it is, and hopefully it's an educated one. So, and that should conclude the ln and the e portion of this piece.